Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the synthesis of citral. How synthesis of citral carried out in the laboratory, that is the actual method for the synthesis of the natural product, particularly citral, starting from the known compound. So that citral first time synthesized in the laboratory by the scientists. The name of those scientists is a Barbier and Boult synthesis. They invented that method in 1887, starting from the known compound like the 2,4-dibromo 2-methyl-butane. They had taken it is a starting material. Along with, they treated this compound with sodium or soda acetyl acetone. Condensation reaction takes place, resulting into as an intermediate, and that intermediate further treated with sodium hydroxide, resulting into formation of the product. The name of that product is a methyl heptanone. This is the intermediate, or what we can call it as a product they have prepared in the first stage. Now, by starting with the end product of the first step, will be starting material for the second step, from which they are going to derive, they are going to obtain, or they are going to synthesize the citral molecule. And now they have one starting material which is methyl heptanone, and that methyl heptanone with the by following the famous reaction, which is a T.Y.B.Sc reaction, well-known reaction. From using T.Y.B.Sc reaction, we are generally getting alpha hydroxy ester. So what will be the material, starting material, or the substrate used for it is a zinc metal and the alpha halo ester. This reaction is known as a T.Y.B.Sc reaction, and the resulting compound obtained will be the alpha hydroxy ester, and that alpha hydroxy ester further treated with acetic anhydride. Heating treatment is given, reflux or boiled at that particular reaction condition. There is a removal of water molecule and form as a alpha beta unsaturated aldehyde, unsaturated ester, and that further treated with the hydrolysis and the lime treatment is given. That step, that catalyst generally used there, and resulting into as a formation of an intermediate, that is the calcium salt of acetate is obtained, and that is distilled with the help of calcium salt of formic acid. Distilled, they had got the pure product, which is a citral product, and that is the terpenoid or terpene we have studied with this. So now today onward, half part of that remaining part of this chapter we are going to discuss. The name is alkaloids, because we are discussing the natural product. Among that, second part we are learning here. So which is the alkaloid? What do you mean by alkaloid? How we can obtain? What is the class of it? What are the properties of that alkaloid? What are the uses of that alkaloid? That type of the information right now today we are going to discuss over here. The introduction. The name alkaloid is given to a group of organic bases of plant origin and which contain at least one nitrogen atom. And whenever there is a nitrogen atom, one general statement regarding as a organic basis, those organic compounds containing nitrogen atom are found to be basic in nature. Why basic in nature? Because the nitrogen atom containing lone pair which is capable of donating according to as a Levy's base theory, which can donate the lone pair. A base is a substance which can donate the lone pair of electron are called as a bases, and therefore the nitrogen atom containing organic reactions follows the Levy's, according to as a Levy's concept, they act as a bases, because nitrogen atom having lone pair on it can be donated very easily, and therefore they are the organic bases, and therefore all the alkaloids containing as a nitrogen atom, and therefore they act as a bases. Okay, and now second thing, say all alkaloids are having marked physiological actions. Remember, all the alkaloids having physiological action. Do you remember the physiological action means what? The body, whatever responses are given by the body, and that type of the actions are known as a physiological actions, and therefore all alkaloids are having marked physiological actions. Basic or toxic action, toxic or curative on the living organism, and these compounds being similar to alkalis in their basic nature, they were called as alkaloids, alkali-like. On the whole, alkaloids are very poisonous, but if they taken in small quantities can act as a medicines. For example, nicotine stimulate the nicotine which is present in the tobacco, as we know that, which stimulate the central nervous system. And morphine relieves the pain. Morphine, you know that this is one of the alkaloid which relieves the pain. Deadly poisonous quinine and quinine, specific for malaria. So occurrences, where they are occur, let us see here occurrences. Alkaloids, here occurrences, alkaloids occur in the leaves, roots, bark, seeds. Means that occurrence, we are talking about the occurrence where they occurs in the leaves, roots, bark, or we can call it as a skin of that plant, the roots, seeds, fruits, fruits of plants, fruits of plants. Where are these alkaloids find? They are occurs in leaves, roots, bark or skin, seeds, fruits of the plants, and they do not occur in the free state. But are present in their salt with organic acid such as they occur in organic acids such as oxalic, citric, tartaric, oxalic, citric, tartaric, malic, the malic acids usually more than one alkaloid occur together in one plant. For example, osmium. Osmium means it is one of the plant where near about 20 alkaloids are present here. 20 alkaloids were present in that osmium. Osmium is one of the plant. Usually more than one alkaloid occur together in one plant. For example, osmium contain about 20 different alkaloids. The alkaloids present in one plant are generally closely related in chemical constitution and properties. So this is all about the introduction of alkaloids we have seen over here. And now let's see another point here, extraction and purification. Next one is extraction and purification. Extraction and purification, that's the point we are discussing right now. And number one here, while extraction and the purification, how it is extracted, from where it extracted, that we are going to discuss here point to point. The plant material containing alkaloids is dried, powdered and extracted with petroleum ether. To remove soluble fats. Second point, the residue is then extracted with methyl alcohol so that alkaloids get dissolved in methyl alcohol, and the residue containing cellulosic acid, cellulosic and other insoluble material is rejected. Rejected means removed out from that. The filtrate is distilled off, and crude plant extract is then treated with dilute hydrochloric acid or sulfuric acid, which has pH maintained at 2. When alkaloids are converted into their soluble salt, which are then treated with ether or chloroform, which are the organic solvent molecule, which are the volatile. The ether soluble part contain non-basic plant material and is rejected. The fifth point, the water soluble plant that is containing salt of alkaloid is treated with sodium carbonate, as we know that Na2CO3 or sodium hydroxide, both are the bases. One is a strong base whereas another one is a weak base. When alkaloid precipitate out, which are then extracted with ether or chloroform. Now is the sixth point. The ether layer is distilled off OFF, and the residue obtained contain a mixture of alkaloids. The individual alkaloid are separated by using technique like fractional distillation, steam distillation and chromatography. These are the various chromatography. From that we can get the pure form of the alkaloids, and that alkaloids, if you use in a small amount, can be act as a medicine, as we learned at the beginning. Now is a powdered plant material extracted with petroleum ether. There we are getting as a two type of the thing. One is a ether part, soluble fats, that is rejected, means removed it, and whatever residue remains there, here that extracted with the methyl alcohol. Again it is divided into as a two parts. One will be the methyl alkaloid part, that is contain alkaloid distilled off to remove the methyl alcohol, and here the residue cellulosic material is rejected on the other way, and whatever crude plant extract remains, in that they have added dilute HCl, pH maintain is a 2, extracted with the ether or chloroform. Again there are two layers obtained. One is a ether soluble part, non-basic plant material, again rejected, and the water soluble part, that is containing alkaloid, further treated with sodium carbonate or potassium or sodium hydroxide, that extracted with ether or chloroform. Once again ether soluble part, and next one is a water soluble part, that is again rejected, and we are getting as a ether soluble part evaporated, and we will get as a residue, and that residue contain mixture of the alkaloids. And by using as a various technique like as a fractional distillation, steam distillation or chromatography, maybe as a thin layer chromatography, column chromatography, or high performance HPLC, high performance liquid chromatography. By using this different technique, we can derive the pure alkaloid, and it is used for the different purposes, for the beneficial of the mankind or for living organisms. This is all about the whatever we have learned, all about the extraction and the purification. Right now we have seen. Now is the general properties of the alkaloid. What are the general properties of the alkaloid that we are going to learn? We have seen these are the some of the part things here. Now we are generally discussing about the properties of the general properties of alkaloids. General properties of alkaloids. General properties of the alkaloids. So remember here, first property of the alkaloid, the alkaloids are colorless. First property is alkaloids are colorless. Generally they are colorless. non-crystalline, they are crystalline, then maybe as a non-volatile solids, non-volatile solids, exception quinine. Second property, they are insoluble in water. Second property, they are insoluble in water. They are insoluble in water, so that is a second property, but soluble in organic solvents, but soluble in organic solvents like ether, chloroform, alcohols, quinine and nicotine are water soluble. Third point, most of them are optically active. Most of them. Third point is most of them are optically active, generally leo-rotation. They are showing specific rotation is a leo-rotatory. That is a leo-rotatory motion. So that is a speciality of these alkaloids. Most of them are optically active, generally exhibit leo-rotatory motion, and they have bitter taste. This is a fourth property, or bitter taste, and being basic in nature, they dissolve in acids, forming their salt that may be readily crystallized. So these are the different or the various or several general properties of the alkaloids we have seen over here. Now is the some alkaloids, their sources and uses are given over here. So let's see there some of the general table we are going to learn over here. From that, the uses. Property just now we have seen. So in exam mention two properties and two uses of the alkaloid. At that moment you have to remember we have seen 4 to 5 general properties of the alkaloids. So you must show at least two general properties of that alkaloids. So some of the alkaloids and their properties that we are going to see in the next time. Let us stop today here. Thank you. Have a nice day.